In order to work tension and compression forces on each of the beams of my bridge, I'm going to begin by working on one of the joints. I'm going to do joint A. At joint A, what we have is the value of the force in Y for A, and then there is two beams. There is going to be the AD, this is 53 degrees, and then we have AB on this part. We really don't know which way these are going, and we are going to find that out. So the first thing to do is to do the sum of the forces in Y. The sum of forces in Y, we know that that has to be equal to 0. And what are the forces in Y? It's going to be AY plus the component in Y for AB, and that's going to be AB sine of 53.1 degrees, and this has to be equal to 0. And you already know what is the value of AY. Remember that this is 350. So that means that I could say that AB sine of 53.1 degrees is equal to 350 negative. 350 pounds. So what I'm looking for is actually AB. So AB is going to be equal to negative 350 pounds divided by the sine of 53.1 degrees. And the value for this will be negative 438 pounds. What this negative means is that this is going to be under compression. And this makes sense. So what this is that this is actually going to be going down. As you can see, this is going down. That makes sense because AY goes up. So let me show you. AY goes up. So this AB is actually going to be going like so. So AB has to counteract the value for the vertical side. Now we're going to also have AD. So as you can see, AB also has a component in X. So this component in X is actually going to help me to find what is the value for AD. So for AD, I will have that sum of forces in X have to be equal to 0. What do I have on X? Well, I have that AB, I already know that AB is going towards the left and down. So I'm going to say that the sum of forces in X are going to be AD minus AB cosine of 53.1 degrees. So I can say that AD is equal to AB cosine of 53.1 degrees. And I already know the value for AB. So I'm going to write down here 438 times the cosine of 53.1 degrees. And this value is going to be 262.5. This is how essentially we can calculate the values of each of these components. And also we can see here that AD is pulling on the joint A. So this value is positive, so it's going to be under tension. So the next joint that I'm going to calculate is going to be joint C. So on C, what we have is our force of 150 pounds. And then we have the beam that is CD. And then we have our beam that is BC. And then we have our angle of 29.7 degrees. And we want to know what the values are for the forces that are acting on BC and on CD. And we want to know if those beams are subjected to tension or to compression. So the first thing to do is do the sum of forces in Y, where I can see that I have the force of reaction force in CY, and I also have the component of BC in Y. As you can see, CD has no component in Y, so I'm not going to count that one here. And these two guys have to be equal to 0. So I already know the value for RCY. Remember, this is the reaction force in Y, okay? So I'm going to say, okay, the reaction force of C in Y is going to be equal to negative PCY. And this is BC sine of 29.7 degrees. So I can say that BC sine of 21.7 degrees equals 2 minus 150 pounds. From this I can get that BC equals minus 150 divided by the sine of 21.7 degrees. And this comes to a value of negative 302. So we can see that this is also, these are pounds, and this is also under compression. Remember, positive is going to be tension, negative is going to be compression. So I have BC already, 302, and it's going to be under compression. So I can say that these little arrows goes that way. And it makes sense because RCY is going up, okay? So now I have the sum of the forces in X. What are the sum of forces that I have on X? Okay, so for the sum of forces in X, what I will be able to do is have the BC component in X, which is BC cosine of 29.7. This is, as you can see, is going towards the right, so it's positive. And then minus CD, that has to be equal to 0. So CD is going to be equal to the value of BC that we just obtained, 302 times the cosine of 29.7. And this has a value of 262.5 pounds. So at this point, what I can do is also update my free body diagram as far as what is happening with the joints. So I can see that in joint A, what is happening at joint B, and what is happening at joint C and D. We have already established that this is the value for AB. We know that A was going upwards, and we know that AD is going this way. So remember that to every action there is a reaction, meaning that for this AB, there will be a force going that way. For this AD, there will be a force going towards the left. We have our forces on C. This one is CY going up. We established BC going this way. For every action, there is a reaction. And then we established that CD was going this way. Therefore, there is a force going towards the right here. Then we have the 500-pound force that is applied on and D, and then I am going to have BD going this way. In order to make this more clear, sometimes it's good to know, so this is BC, this is DC, this one was AB or AB right here, this guy is BC. So we already have all of our forces in C, in A. All we need to do is find the forces. Essentially, the one that we're missing is going to be BD. And I already know the value for AD, for DC, and I have this 500. So adjoint D, what are the forces that I have? So DC, I already found, it's on X, AD, I already found. So what I'm going to do is just find BD, that is going to be the opposite of 500, and those are the only forces that I have. So the sum of forces in Y tells me that BD minus 500 equals 0. BD is going to be therefore equal to 500 pounds. And this 500 pounds is positive, so it's under tension. So I know that it's going to be the arrows like so. And this is the way that we end analyzing each of the trusses in a structural bridge or something like that.